Welcome to West Virginia. All right, so are you ready for joke of the day? Because it is the best part of the day. Now, my joke today is, what's so great about living in Switzerland? Well, the flag is a big plus. Anyways, let's get on with our next topic, and that is polynomial equations of degree 3 or higher. So what we're going to be looking at is how to solve polynomial equations that, notice in this particular one, we've got a highest exponent of 4. So whenever you've got polynomials and you have an equation in there and your degree is anything 3 or higher than that, one of the ways that you can solve it is that you can just simply factor it. Now this is based on that zero product principle that said whenever you've got things that are multiplied together and you get a 0 in the end, then one of those has got to be the 0. So what that indicates to us is that we need to take our polynomial equation and we need to factor it. But in order to use that zero product principle that says I'm multiplying things together to get a 0, that means that the equation needs to be set equal to 0 in order to employ that, that zero product principle. So what I'm going to do then is I'm going to move all terms to one side. And set it equal to 0. And then once I've moved everything to one side, it's set equal to 0, then I'm going to factor it. And then as that zero product principle says, then I'm going to set each factor equal to 0 and solve. Set each factor equal to 0 and solve. So this should sound familiar because this is one of the ways that we use to solve a quadratic. One of the methods, where there were 4 methods for solving quadratic, and one of them was to factor and set each factor equal to 0. So this is going to feel familiar. So remember that whenever you factor, you always look first to see if there's something common that you can divide out before you do anything else. Well, as I look at this and notice that this is set equal to 0, so my first step has been done. And as I factor this, I'm noticing, hey, you know what? I can take a 5 out of each one of those terms. And I can also take an x squared out of each one of those terms. And I'm going to write down in a parentheses what's left. When I divide this by a 5x squared, I'm left with an x squared. When I divide this by a 5x squared, I'm left with a negative 4. Now remember, you should always look inside that parentheses to say, is there anything more that I could do with that? Can I factor it any further? And in fact, you can. Because that x minus 4 will factor as an x plus 2 and an x minus 2. Because notice the back sign tells me I've got opposite signs. Split this up into the front slots. It splits as an x and an x. Split this into the back slots, and 9 times out of 10, if it'll split evenly, that's what it'll do. And if I check my outsides and insides, outside I get a negative 2x, inside I get a positive 2x. Yes, those do cancel, and they needed to because I don't have a middle term. So I can take my x squared minus 4, and I can factor it further into this double parentheses. Now don't forget that 5x squared that's sitting out front, because remember, I need to be able to multiply all this out and get back to the beginning. If this is all I have, then I can only multiply and get back to here. But I need to get back all the way to the beginning. So now I have factored, and what my zero product principle says is each one of these could be the 0. So either that 5x squared is the 0, or the x plus 2 is the 0, or the x minus 2 is the 0. Now if the x minus 2 is the 0, then that means my x is going to be a 2 because I'm just going to add 2 to both sides. If my x plus 2 is the 0, then my x would be a negative 2 because I'm going to subtract 2 from both sides. And here, if I divide by 5, I get x squared equal to 0. And if I take this and I take the square root, then that tells me that my x is going to be 0. So I've got x equal to 0, x equal to negative 2, and x equal to positive 2. These are the 3 numbers that I can put right here, raise it to the 4th power and times it by 5, put it right here, raise it to the 2nd power, multiply it by 20, subtract the 2, and I am going to come up with a 0. Now recall before we had looked at restrictions on the domain. There are no restrictions on the domain here because there's nothing that would cause zeros in denominators or any other strange things happening. So these 3 numbers are perfectly fine, and I don't really need to check other than to check, put them in there and make sure that they really do work. Now, let's take a look at another example. And in this one, notice that it is degree 3 or higher. I have third power right here. So that tells me that I'm going to factor, 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 and set each factor equal to 0. Well, in order to employ that zero product principle, then that means I have to have everything on one side set equal to 0. So I could slide both of these to this side, or I could slide both of these to that side. It really makes no difference. Most people like to have their highest power positive. So what I'm going to do then is I'm going to slide both of these over to the other side, which means I'm going to subtract my 18y squared. I'm going to subtract my 4y. Now this 8's going to stay positive, and it is set equal to 0. So now I'm ready to factor this. Now remember, with a 4 polynomial, the best way to factor it is to pair things up. So I'm going to pair up these two, and I'm going to pair up these two. And then I'm going to see what's common to each of the pairs that I can divide out. So I'm looking at both of these and I'm saying, hey, I could divide a 9 out of both of them as well as a y squared. When I do that and I divide that 9y squared out of here, I'm left with y. And when I divide this by 9y squared, I'm left with a negative 2. Now here, what's common to both is a 4. So I'm going to divide that 4 out. Now if I divide a positive 4 out, I'm left with a negative y plus 2. But if you recall with those 4 polynomials, what I want to happen is I want to have what I call a funky looking term, or a very strange term here and a strange term here. And I want to have within the two boxes the same parentheses. But notice that my parentheses is pretty close. They both have y's, they both have 2's. But this is a positive y, that's a negative y. This is a negative 2, that's a positive 2. Well, in order to fix that, what if instead of dividing out a positive 4, I divided out a negative 4? So when I divide this by negative 4, I get a positive y. And when I divide this by negative 4, I get a negative 2. And voila, I have the same thing in both of those parentheses. So now that I've got identical parentheses in both the boxes, I'm going to divide that common parentheses out. So my y minus 2 will be divided out, and I'm going to write down in parentheses what's left. I'm left with a 9y squared and a negative 4. Now remember, I'm going to look and say, is there anything more that I could do? There's nothing more that I could do with this, but there certainly is with this one. So I'm going to keep my y minus 2, and that 9y squared minus 4 will factor as a 3y plus 2 and a 3y minus 2. Because yet again, back sign here tells me opposite signs. Split this, and if it splits evenly, 9 times out of 10, that's what it's going to do. So it splits as a 3y and a 3y. Once again, if this splits evenly, 9 times out of 10, that's what it's going to do, a 2 and a 2. If I check my outsides, negative 6y, and my insides, positive 6y, they cancel, and I needed them to because I don't have a middle term here. So that is the correct way to factor it. Notice there's nothing more that I can do here, nothing more that I could do here, and nothing more that I could do here. So I'm going to set each one of these factors equal to 0, because what I have here is 3 parentheses being multiplied together to get a 0. So one of these 3 has got to be the 0. Either that y minus 2 is the 0, or the 3y plus 2 is the 0, or the 3y minus 2 is the 0. Now if the y minus 2 is a 0, I'm just going to add 2 to both sides and get a y equals 2. If 3y plus 2 is the 0, I'm going to first subtract 2, and then I'm going to divide by 3, so I'll get y equals negative 2/3. And here I will add 2, and then I'll divide by 3, giving me y equals positive 2/3. So here are the 3 numbers that I can plug right in here, here, and here, do all the order of operations, and get the left side and the right side to be the same. So notice that, and once again, if you've got 3rd degree or higher, you're going to set it equal to 0, factor, 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 and then solve each one, so each one of those factors equal to 0 and solve for that. Again, I don't need to worry about restrictions on the domain because there's nothing happening in here that would cause zeros in the denominators or anything other that's strange. So let's take a look at one more, the one that I just erased. We'll flip this over. And what I'm going to do is I'm going to erase these steps and use the top part of the board. Enjoy all the craziness that's happening behind me in this circus. It is a zoo out here, or a circus, whichever the case may be. Okay, so one more example. And in this one, I have 3x to the 4th equal to 81x. So once again, this is 3rd degree or higher. It's 4th degree, so that means I'm going to set it equal to 0, and then I'm going to factor, and then set each factor equal to 0. So I'm going to subtract my 81 first, or my 81x that is, and now I'm ready to factor it. I'm going to find what's common to each one of them. Both of them are divisible by 3 and an x. So when I divide this by 3x, I'm left with x to the 3rd. When I divide this by 3x, I'm left with a negative 27. And now I'm going to look at this and I'm going to say, can I do anything more with that? Well, in fact, I can, because this is a difference of cubes. And recall that with a difference of cubes, you've got your cube of soap. And remember, S stands for same, O stands for opposite, and AP stands for always positive. And so what that tells me is my difference of cubes factors as a binomial and a trinomial. And I'm going to fill in the signs of the binomial and the trinomial with my cube of soap. So S being same means whatever this sign is, I'm going to carry it over as the same sign. Then I'm going to do the opposite sign here, and this back sign will always be positive. Now what I'm going to do is I'm going to take the cube root of this, and it's going to go right here. The cube root of x to the 3rd is just an x. I'm going to take the cube root of this one. Cube root of 27 is a 3. That will go right here. And now to fill in the trinomial, I'll take this and square it, and it'll go right here. I'll square this, but it goes in the back. 3 squared is 9. And I'll multiply the two together and put that in the middle. Now you may be thinking, hold on, an x times a negative 3 is a negative 3x. But recall, we already filled it in with cube of soap, so we're okay here. So now, there's nothing more that I could do with this. I cannot factor it any further because remember, this is a pattern. Sum and difference of cubes are patterns. And once you have factored this way, you cannot take this any further. So I'm stuck as far as factoring goes. So now I'm going to set each factor equal to 0. So the first term could be the 0. The second term could be the 0. Or this back term could be the 0. Well, not back term, but first term, second parentheses, third parentheses. Now, if this is the 0, I'm going to divide by 3, and that'll tell me that my x is 0. If this is the 0, I'm going to add 3, and that'll tell me my x is 3. Now, in this one, I have a quadratic. And recall that I've got 4 methods for solving quadratics. One is to factor, which is the easiest and best way to go. However, if this could factor, I would have already done it, so that's not an option. I can take the square root of both sides. Certainly don't want to do that here because this first power term is completely messing that up. My other option is to complete the square. Good option, but most people at this point will choose that quadratic formula. So I'm going to head for the quadratic formula, which says negative b plus or minus square root b squared minus 4ac all over 2a. Hey, quadratic formula! So now I'm going to plug those numbers in. My b is a 3, so I want the opposite of 3, plus or minus square root of 3 squared minus 4, a is a 1, and c is a 9. All over 2 times 1. So now what I'm going to do, let me erase this and give myself a little bit of room. I don't want to erase all of it because I do want to refer back to it. But let's clean it up and give ourselves a little bit of room here. So I have negative 3 plus or minus 3 squared is 9. 4 times 9 is 36. All over 2. And so now what I have is negative 3 plus or minus square root of negative 27 over 2. Now recall that whenever you have a negative underneath the radical, you need to pull an I out. Let's go right over here. Negative 3 plus or minus I square root of 27 all over 2. And then recall that square root of 27 means 9 times 3. And the square root of 9 is going to be 3. So that means this is a negative 3 plus or minus 3i square root of 3 over 2. Which, yes, is a complex number. It is imaginary. However, here are the solutions to this fourth degree polynomial. I've got 2 here, negative 3 plus 3i squared root of 3 over 2, or negative 3 minus 3i squared root of 3 over 2. There's 2 solutions here, plus my x equals 0 and my x equals 3. And those are the 4 solutions to this fourth degree polynomial. Now, let me step back and point something out to you that's very interesting. Notice that in this last example, we had a fourth degree polynomial and we came up with 4 solutions. 2 here, 1 here, and 1 here. Notice as well, in the second example, we had a third degree polynomial, and how many solutions did we get? 1, 2, 3. So interestingly, it appears that the degree of the polynomial will tell you how many solutions that you've got. So I had 3 solutions, it was a third degree polynomial. I had fourth degree polynomial, and I had 4 solutions, 1, 2, 3, and 4. Here's where it gets kind of weird. Notice in this one, it was a fourth degree polynomial, but how many solutions did I come up with? 1, 2, 3. However, if you recall, the step right before this said x squared equal to 0. So I take the square root and I take the square root. As a technicality, when you take the square root, you would get positive or negative. Now 0 neither is positive or negative, but there's that idea of 4 solutions. But actually, the degree of the polynomial tells you at most how many solutions you will have. So at most, I should get 4 solutions. Having 3 is perfectly fine. At most, I will get 4 solutions, and I did get 4 solutions. And in the previous example, I will get at most 3 solutions here, and I did get 3 solutions. So this is how you solve your polynomial equations, degree 3 or higher. You set it equal to 0, and then you factor, 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 set each factor equal to 0, and then you take off with that. So I hope it helps. Have a great day.